In this lecture, we're going to learn all about Unity addressables. This enables you to have more control over your assets. Instead of everything being loaded automatically, it only loads when you ask it to, so it helps you manage memory and also loading times, which can be an extremely important thing. Especially when making mobile games, you want your game to load as quickly as possible and then load some assets over time when they are needed, instead of forcing the player to stare at the loading screen for a long time. Also very importantly is Addressables is entirely asynchronous, so you're never waiting for your assets to load by looking at a frozen screen. It loads in the background and notifies you when it's ready. And there's also another part to this system which I'm going to cover in the next 2 lectures, which is how you can store those assets in a server in the cloud and dynamically push them to your players so they can get updated assets without having to push another build. You can download those assets from any server, like your own server, perhaps your own CDN, or a Unity solution called Cloud Content Delivery. But again, that's all in the next 2 lectures, so before that, let's just learn how it works locally. Okay, so let's start using addressables. This is one of the most requested topics on the comments for this course, so let's learn about it. Thankfully, it's actually pretty simple and extremely powerful. Over here, I've got a simple empty scene, and all I have is a simple massive object. This one is pretty much an entire living environment, so if I drag it, it even takes quite a while over here in the Unity editor. There you go, just a massive environment with tons of objects. This prefab is intentionally meant to be really complex with lots of objects, so we can then see the memory footprint. Let's first quickly see the main problem that addressables help solve, and then we're going to use it to fix it. Now with this, if I just hit on play, and yep, there it is, the game is playing and the object is here as you expect. But let's say you don't want to spawn the object right away, you want to spawn it on a player input. So for that, let's make a simple script. So let's create a new C# script, call it spawn object. Let's make a new game object to run it. Attach the script and open. So now here, let's listen to simple input. So let's just do a private void update, and over here, let's get a key down. Let's say the T key. So when you have this, then over here, let's instantiate a prefab. So let's add our reference here as a serialized field, a private transform for our prefab. So we have this, and then when we press, let's just call instantiate on this prefab. Alright, that's it, super simple. So this is the basic way to instantiate an object. Let's see. Here in the editor, just drag the prefab and let's hit on play. Okay, the game is running, there's no object, now I press the button, and yep, there you go, it gets instantiated and spawned. Okay, great. So again, this is the standard way for how you can instantiate any prefab. However, when you do it like this, if you were to load this scene, even without actually spawning the object, it would still be included in memory. Basically, anything that is referenced in the scene, like for example, over here we have a reference on this object, because it is referenced by this object, it is going to be loaded when the scene loads, whether it is placed on the scene or not. We can make a quick build just to test it out. So let's just go into File, Build Settings, make sure to include this scene, and let's make a simple build. Alright, so here I've got the executable. Now let's click on it to open it, and then count how many seconds the loading is actually going to take. So let's double click and wait for the win. There we go, 1, 2, 3, 4, 5. Alright, there it is, so it took about 20 seconds to open. So that's the unloading time. Again, it's because it had to load that entire object into memory, even though again, right now we're looking at the scene and the scene is completely empty. And we can look in the task manager to see the memory footprint. Over here we can see the executable is indeed taking 680 megabytes. Now if I press the button to spawn it, and there you go, it does spawn it, and as you can see the memory barely moved. So this is the problem. Ideally you don't want that object to be loaded into memory until it's actually needed. Doing so will massively speed up the unloading time as well as memory usage while the object isn't being used. Just think of how impossible it would be to make massive games like Skyrim or GTA if you had the entire world loaded at all times. It would be pretty much unplayable. So now that we've seen the problem, let's learn about addressables and how they fix this. The first thing that we need is the package, so let's open up the window, open up the package manager, and then over here let's make sure we are on the Unity registry, and then scroll down and find the addressables package. So there you go, just go ahead and install it. Okay, it's installed. Now to open up the main window, let's go up into Window, under Asset Management, then Addressables, and let's open up the Groups window. Okay, this is the groups, and as you can see, we need the button because we pretty much need to create the addressable settings. So let's click on this button to create it automatically. And there you go, that creates a bunch of files that the addressable systems uses. And over here we can now see the groups. And by default, it creates a default local group. Then manually, you can right click to create any groups that you want. So you can have as many groups as you want. Each of these separate groups is going to be built into a different asset bundle, but we're going to worry about that in a bit. So for now, let's stick just with the default group. Okay. Then once you've got the groups assigned, let me just drag it up here. So with the groups assigned, we can now add some objects onto it. And there are multiple ways to do it, and the simplest way is really just to drag and drop the object. So let's go over here into my project window. I've got my environment, so let's click and just drag and just drop it inside the local group. And there you go, it automatically adds the group, so I can see over there the environment prefab being added, and over here I've got the path to the environment. So with this object is already marked as addressable. Alternatively, you can select the file in the project files, and over here in the inspector you also see a toggle for addressable, and then you also see the underlying path. Now over here you can write whatever you want, you can modify the path if you want, but chances are you should really stick with the default path. We're going to see what the path means in a bit. Also, don't worry if you're already scared by the fact that the path is a string. We're going to see non-string methods for using addressables. Another option you have is simply to mark an entire folder as addressable. So for example, if you want to load tons of assets at once, you could make the folder itself addressable and load that. For example, over here, I've got a folder with a bunch of sprites inside. So instead of going individually and individually marking each of them as addressable, I can just drag the folder and drop it over here into my group. And there you go, I've got an entire folder marked as addressable with all of the objects inside. Okay, so now that we have our environment prefab marked as addressable, let's load it through code. So first of all, before we do that, let's actually get rid of the previous script, the previous reference. Make sure we delete this, so this one is not included in the build, okay? Now let's make a new C# script. So let's create a new C# script, call it spawn object addressables. Let's make a game object to run it, and let's attach, okay? Now here, first thing we need is our namespace, and the main addressables namespace is inside using Unity engine.addressable assets. Then let's make some simple input, just like we did a while ago. So avoid update, if input, let's get a key down on the T key. So that happens, let's load the object using addressables. And how we do that, we access the actual addressables class. And over here, let's use the function load asset async. Again, the entirety of addressables is asynchronous. The non-async methods, like for example here, load async, you can see this one is marked as deprecated, so you are not supposed to use this. You are only supposed to use the async methods. Just in case you don't know, async means asynchronous, which also means that it doesn't block the main game thread. So the game never freezes, it keeps playing as an asset is loaded in the background in a separate thread. So let's use this function, and this one takes a key. This is going to be the path to our asset. So here in the addressables window, let's copy this path. So let's select it, copy the path here, and let's use it here. This one is a string. Again, don't worry if you're not a fan of strings. We're going to see a method that does not require strings in a bit. So that's it, just using the string, that's the only parameter it takes. Then also this function, as you can see, is a generic, so that means that we're going to return some type. And for this one, for a prefab, let's make it work as a game object. All right, so we have our function to load an asset, and we can see what this returns. So this returns an async operation handle. Let's add the using statement. So we've got async operations, and this one is going to return that. So an async operation handle of type game object. Okay, so we have this. And then on this operation handle, over here we can subscribe to the completed event. So let's listen to this event. And when this event happens, over here we've got the same async operation handle. Then on this one, first of all, we can check if the operation is successful. So let's check if this one dot, let's check the status. So if the status is succeeded, if so, then we have our object, and if not, then there was some kind of error. So fail to load this object. But if it did succeed, which it should, if so, then over here we can call instantiate. Let's spawn our prefab. So let's go inside the async operation handle, and inside to grab the resulting object that was loaded is inside the result. This one, as you can see, takes a game object, which is the type that we're using. Okay, so that's it. We go into the addressables. We ask it to load an asset asynchronously. We give it the path for the asset that we want to load. This returns an async operation handle because, again, this one is asynchronous, so this is not complete the loading immediately. It does not block the game, the code continues to run. Then grabbing on this one, we can listen to the completed event. So when that eventually finishes loading in the background, when that happens, this function is called, we check if it succeeded, and if so, then we finally instantiate the game object. Okay, so with this, let's test. So here we are, and there's no object in our scene. Now I press a button, And this time it takes a bit longer, but yep, the object is dynamically loaded in the background, and when it's ready, the object is spawned. Okay, great. So just with this simple thing, we can already compare with the previous demo. So let's make a build to see that. Let's do the exact same thing, just save the scene, go into File, Build Settings, and let's make a build just like the same. Okay, so now it's making a build, and this time it actually takes a bit longer to make the build since it's also going to be compiling and compressing the asset bundle. Okay, so the build is done. Now, once again, let's pay attention to the unloading time. So let's double click and wait for the window. And okay, 1, 2, and there you go, in just 2 seconds instead of 20. So as you can see, much faster. The reason for that is, of course, because it's not automatically loading that object at runtime immediately when the build launches. And we can verify that by looking in the task manager. So yep, here we do see we are currently only using up 137 megabytes. So nothing close to the 600 or 800 from before. And now if I press the button, now the object is being loaded. You can see over there it's currently reading and writing to the disk. So it's loading everything currently into memory. And after a bit, yep, here is our object spawn and the memory did go up. So just with this simple demo, we can already see the massive difference that it makes. Our game loaded much faster and memory usage stayed low since the object was only loaded when we actually needed it. Okay, now let's keep learning some more about addressables. Like I said, this is just one method to load. You can write a path string and load it. Also, we can simplify this like with any callback. So instead of having to define a separate function and storing our async operation handle, let's just call this. And then immediately when we call, let's subscribe to the completed event. And instead of using a separate function, let's use a lambda function. So let's define an async operation handle and do a lambda function. And then inside, we're going to do the same thing that we're doing here. All right, so there it is. We're still doing exactly the same thing, but everything is much more compact. This can be useful because it does not require a separate function definition. So like I said, this method is using a string for the path. As a general rule, you should always avoid using strings as much as possible. Strings are super brittle. It's really easy to make a mistake with any of it. For example, if you just miss one letter or just capitalize, so the I put it capitalized. If I do this and we test, yep, there we go. We have an error because again, the string path, this one is case sensitive. So as you can see, strings are very brittle, very easy to make mistakes. So let's avoid using strings. And the best way to do that is using something called an asset reference. Let's make it a serialized field so we can set it in the editor of type asset reference. Let's see in the editor what this looks like. So there it is, we've got our reference, and now if we want, we can drag it straight from the addressable groups. So if I drag the environment, drag it on top of there, yep, there you go, it does work. I can also drag the prefab from the project window, or alternatively, I can click on the little search button, and over here select any of the addressables included. Also, if you drag a different asset that is not included in the group, so right now these are the only ones in the group, and over here I've got another environment small. If I drag this one on there, you can see, yep, it does drag it on there and automatically adds it to the group. Okay, so we have our asset reference. Now over here, we can load this asset reference directly. So we just go to this one, and inside this one, let's call load asset async. And again, let's do the same thing, give it the type. So the game object type, and we're going to load it, and this one takes no parameters. And everything else is pretty much exactly the same. So let's actually get rid of this, and yep, everything else is exactly the same. So this function still returns an async operation handle. Everything still works the same, except now we don't have strings. So let's test this to see. So here we are with nothing, press the button, and yep, there you go, it does spawn the object. Okay, so that's the asset reference method. Another way to load an asset is with a label. Over here in the addressable groups, we can see over here we've got a part for the labels. And if we click on each of these drop-down menus, we can see all of our labels. And of course, we can add some more. So let's click on the little gear icon, and over here we've got a list of all of our labels. Let's create one, let's call it environment. Then we can close this one over here for the environment small, let's put it on that one. Also when it comes to labels, you can have multiple objects. So if I want, this one can also be on there, and you can also assign multiple labels. So if I click on this, yep, you can select multiple. Alright, so this object now has a label. And for loading, we can use the same method as previously, using the key. The key can be a path or it can be a label. That would work just the same. Or again, if we want to avoid strings, we can use a different thing. This one is an asset label reference. We can use this. Here in the editor, it has a nice drop-down menu, so let's select the environment label. Then here in the code, how we load it is by using the previous method, so addressables, load asset async of type game object, and for the key, let's pass in just the asset label reference. So just this one, then it's the exact same thing, go into the completed and so on. So let's see this. So here we are, and I press the button, and yep, there you go, it does load. Okay, so everything is working correctly. Now with this asset reference, you can reference anything. So for example, over here on the asset reference file, you can see that I've got some sprites that I dragged in there. So if I go, I can select one of these. However, over here in the code for this asset reference, let's go back into the previous method. Over here, we are loading this asset reference as a game object. But here in the editor, we drag the sprite reference. If we try running this code, and I press the button, and there you go, got an error. We can see the error is because the asset exists as a texture 2D, which is not assignable to the requested game object type. So this is the error, the code is expecting a game object, but over here I dragged a different reference because I can drag any reference onto this field. As another example, over here I've also got some audio files, so I can also drag it on there, and there you go, that one goes in there. And again, this one would also cause an error. So asset reference can be quite error prone, and to solve that, there are some helpful reference types that force some limitations on the type of the objects. For example, we have asset reference game object. This one, like the name implies, only receives game objects. Then we've got two more. So asset reference, we've got a texture 2D. As you can see, we have a sprite, atlas sprite, and so on. So there are multiple of these to enforce a specific type. We can see this in the editor. So we have this game object. Let's put this one there. Let's see it. So here we have the asset reference game object. And if I try to drag the coin reference, nope, I can't do that. Try to drag the audio clip, nope, does not work. It only works if I drag an actual game object. So this would help prevent that error in the code. However, as you can see, there aren't all types. So for example, there isn't any type for an audio clip. But if you need that, then you can actually create it yourself. If we inspect the code for this, we can see that this is pretty much just a class that extends asset reference T and then has a type and just has a constructor with the GUID. So you can pretty much just do this for any type we want. So for example, let's go up here, let's make a public class. Let's call it asset reference audio clip. Let's extend asset reference T and then inside put the type. So in this case, audio clip. So we have this and we just need to implement the constructor. So let's use the helpful Visual Studio to create it automatically. So here it is, we don't need any behavior, anything at all. So that's it, this works. Now, obviously, in order for this to show up in the editor, we need to mark this as serializable. So system.serializable. Okay, and now here we can now use that one. So we can use an asset reference audio clip. Okay, let's see this in the editor. There's the asset reference audio clip, and clicking on the button, yep, the only thing I can select is indeed an audio clip. Then for loading any of these separate types, it works exactly the same as previously. Also, one more thing is you can immediately instantiate a reference directly. So for example, when working with game objects, that can be a bit faster than doing all of this. So we can go into that asset reference and call instantiate async. We can optionally give it a parent, instantiate in world space, give it a position, quaternion, and so on. Or if not, let's just do this. And now this one also returns an async operation. So if you want to know when this actually completes, you could subscribe to this. Or just don't do that and just call instantiate async. So let's comment out this so we only run this code. And if we test this, so here we are and press the button. And if there you go, the object is spawned automatically. So if you want to spawn, then this is much more compact than this. Now, like I mentioned, you can make an entire folder as addressable. So let's see how to load multiple assets at once. Here in the addressables group, I already made my special sprites folder, which inside has a bunch of sprites. This one is now an addressable. Then here in the code, let's load the entire folder. So let's go into addressables, and then instead of going into load asset async, let's go into load assets async, plural. Let's load a bunch of sprites. Then it takes a key, so this is the path, pretty much like we already saw. This one can also take a list of keys, so we can give it a list of string. Then here we can type one path, then another path, and so on, and it will load all of the objects. Or alternatively, we can also load the entire folder at once. However, this is actually a bit tricky. It took me quite a while to figure this out. If you just type in the string for the folder, so here in the group, if you look in there, this is the path, so let's copy this. So over here, if I paste that path, If you use this method, then yep, here we can see we get an error. Alternatively, on the asset reference field, you can drag the folder and drag it straight in there. Then over here, try to use the asset reference in there. However, if we try this, and nope, this one also gives the same error. So basically, we cannot load the folder directly. The folders that we see over here inside the addressables group, this one is really just meant for organization, meant for organizing all of the objects inside it, but you cannot reference the folder directly. So the only two options to loading all of these objects would be to either manually drag the reference for each individual object, but that kind of defeats the purpose of having a folder with multiple objects. So another better approach is to simply make a label. So let's click here, let's go manage our labels, let's make a new one, special sprites. Okay, we've got a label, so now let's assign it over here. And yep, as you can see, all of the objects inside the folder, all of them get the exact same label. And now, in order to avoid using strings, we can go into our object, and on the asset label reference, let's use that label. Then over here, let's use the asset label reference like that. With this, now it will indeed load everything in that folder. And then the function over here, as you can see, has a second parameter. This is an action that is going to run on every asset. So let's grab the sprite that is going to run, and let's just do a log on it. So debug.log on the sprite. Okay, so let's test and see if we see a log for every single object inside that folder. So here, if I press T, and yep, there you go, all of the objects. So $gamepad coin, which are exactly all of the sprites that I added to this folder. Also, one more thing on folders, if you make a folder addressable and then you drag another object inside that folder, so for example, if I duplicate an object here, so I did not specifically make this object addressable, but since it's inside an addressables folder, then it automatically becomes addressable. However, there's actually a small bug over here on the addressable groups window. As you can see, I add that one, so I've got $and $1. I've got those two objects, but over here I can only find $. It does not show the other one. However, again, this is just a visual bug. If I close the addressables group window and I open it up again, so let's go into Window, Asset Management, open up the groups, and I expand it, and yep, there you go, over here I do see the $2. So whenever you add objects, so for example, if I take it out, then it's no longer in there, but over here it still is, so this is just a visual bug. Anything you put inside this folder will always be included. So if I run the build, and I'll press the key, and over here, yep, we do see all 4 sprites. And of course, since you can load objects at runtime, you can also unload them. For that, you can use addressables.release. You can use this one and pass in the async operation handle. Alternatively, you can go into addressables and use release instance. This one is useful if you previously used instantiate async. So for example, let's test this. So let's grab this one. So we call instantiate async. And now we need to keep track of the instantiated object. So a private game object for the spawn game object. Then over here we call instantiate async. Let's listen to the completed event. So when this happens, we've got over here the spawn game object. So let's simply set the spawn to this game object. Although actually this one does not have a game object, it has an async operation. And then inside it we get the result, and that is what actually contains the game object. Okay, so we've got the spawn game object reference. Let's make another input. So if input get key down. And on this one, now let's use the same reference and call release instance and pass in the spawn game object. All right, so that's it. Let's just comment this out. So let's make a build and look at the memory and see what this does. Okay, so here's the build. Again, since I'm using addressables, the memory footprint is real low, so only 136. Now I press the button to load the assets. And there you go, it starts loading them up. And yep, here it is, so the memory went all the way up to 616. Now I press the button to unload it. And yep, there you go, the object is destroyed, and over there the memory comes back down. Also, another thing is the assets are automatically unloaded from memory when you do a simple scene change. So if you were to add Unity engine.scene management, and then up here on a scene, if you would do scene manager.load scene, if you would load a different scene, then yep, it would automatically destroy the objects and release the memory. Although do keep in mind this only works automatically if you use single scene mode. If you're using additive scene loading, then they stay loaded since Unity does not know which assets you no longer need. Now there are some more things related to addressables if you want to dive deeper. For example, as we saw, you've got a bunch of profiles. So you can click here to go into Manage Profiles, or alternatively go into Window, Asset Management, Addressables. Let's load up the profiles. Now these are used for easily setting up, for example, a profile for testing, another one for production, and so on. As you can see, each profile defines where exactly is the local and the remote paths. I cover how to handle the remote paths in the next lecture. Then another helpful window is, once again, go into asset management. Over here we've got the settings. Then here you have tons and tons of options. Another one you have is also the useful events. So if you see here the event viewer, this one, as you can see, has a warning. So you need to enable over here on the settings, send profiler events. So this one needs to be enabled. And now if we try running the game like this one kind of acts like a profiler. So if I go and now look in the console and I press the button, and there you go, it does start loading the things. And after a while, yep, it instantiates the object. So you can stop at any point and see exactly what it did. Then over here, you also have the Analyze window. This one lets you pretty much see dependencies. It analyzes all of the rules that you define and finds all of the dependencies within your asset bundles. And finally, there's the Hosting window. This one is for a more complex use case where you want to connect to an external host to let you upload builds and content. Okay, so all of that is the basics of addressables, a really useful way to have more control over your memory and dynamically load your objects. This one helps cut down on loading times and general memory usage. You pretty much only load the assets when you need them. And of course, this lecture is just the basics. The next step is to load updated assets from the cloud without having to make a new build. So we're going to learn how to do that in the next lecture. And then in the lecture after that one, we're going to learn how to use Unity's Cloud Content Delivery as a CDN for all of our assets. So if you're interested in addressables, definitely keep watching the next few lectures.